Hello, folks. Okay, so I wanted to describe the XML Nesting Validator assignment. It's an X-credit assignment. And your first question might be, what is XML? So XML is a file format that's sort of self-documenting. Imagine a document for a message with a to and a from and a heading for the message as well as the body of the message. Then XML would then perhaps put that all together in an XML tag called note. The open tag looks like so, and the close tag, it looks similar, almost the exact same, except it's got a slash in front of the word. And then in addition, then the who it's to and who it's from are marked up with tags, okay, that describe the data. And since it's self-describing, it's a pretty popular way to store data in data files as well as transmit data across the internet. There comes with a bunch of rules. And the principal rule we're going to be investigating here is the nesting. So if you open the note tag and then open the to tag, you have to close the to tag before you ever close the note tag. In that sense, it matches our in-class activity where we were doing parentheses matching and brace matching and brackets matching. Just to illustrate that a little bit further, here's an XML validator that W3 Schools provides. And it's the same document there, except I forgot to close the heading tag here. At that spot, there's no close heading. And if you check the XML, sure enough, it'll show up that way, where it says there's an error, but it's basically a tag mismatch. And heading on line 5, as well as note. Turns out note happens a couple of lines later, but okay, so that's what we're going to try to do with our program. Okay, and so then let's go ahead and take a look at the assignment. In this assignment, then I'm already to provide an XML tag class for you. This is basically has enough information to describe one tag, the tag name plus its location inside the string. Also, there's going to be a stack interface that you folks will have to implement this thing. Well, let's go take a look at the files over in our IDE. Here's the tag, XML tag class. It's got the name field, and that one I would recommend in our example here, that would have like the word note, okay? I would recommend also that in the name you do not put the entire tag, including the angle brackets and such, for a number of reasons, but not the least of which ultimately you're going to have to match up the tag against the closing tag name, okay? And if you do the whole tag here, the angle brackets, that's never going to match up here. All right, but tag names will. And then for the index, ultimately we'll be worried about line numbers, but my recommendation to you is that you save the linear index inside the string and only change it to a line number at the very end. Okay, but anyway, so XML tag class already written for you. And the XML tag stack interface is given to you as well. It's got a few methods like push and pop and peek and get count as we described in our class. And a couple things to say here. First of all, just getting the stack to work, you're going to be implementing basic XML tag stack, which implements this interface. Just getting that to work is worth a couple of extra credit points, I think. And it's a pretty simple thing to do. You can use the guidebook as a reference, or just use ArrayList to implement your stack. Okay, and then just provide each of these methods. So you get a few extra points for that. All the work related to this check XML here and the figuring out that there was a problem, a tag mismatch, that work all happens inside the XML validator interface and its method called validate. You will then provide a class called basic XML validator that implements the XML validator, and you might notice that it really only has one method, validate. So let's go look at that one. Yeah, this one's got a ton of documentation to read about, but roughly speaking, the outside world is going to pass you an XML document, and the first mistake students often make here is that this one is not a file name. It's the actual string contents of an XML document. Okay, so it's the XML itself. The output from this thing is either, let me see here. Yeah, if the XML document elements, they're all properly nested, then null is returned. Okay, so if all's good, you don't find any errors, then just return null. But if I give you a document that has got an error, an example being again back here, notice that here's an XML document, and if you read through it, you'll see that, oh yeah, it's missing the header here, or the heading close. In which case, the problem that you bump into using the nesting validation algorithm we talked about in class is that heading is an opening that doesn't match this note that's closing. By the way, the problem doesn't occur when you get to body here because you'd ultimately do pushes and pop in here. You'd push heading on, then you'd push body. And when you bump into this closing tag, you'd pop body off the stack and they'd match up and they'd be a good match. But when you hit this close note, the top item of the stack would be this heading and they would mismatch. Okay, so how are we going to describe that in the return value from a function? The way that I decided to do it was like this. I want you to pass back a list, in this case of size 5. An example is, let's say, I think this one is hard-coded text in spot 0, tag mismatch. This would be the opening tag that is mismatched and the line number where it happens. And here's the closing tag that didn't match up and the line number that it happens, where it happens. Okay. In this sense, because we're actually providing the line number where the closing tag mismatches, we were actually going a little bit past what this thing does. Again, this one sort of shows that, I guess maybe it does show that on line 7 is where the mismatch occurred, and it's between line 7 is where note happens, and line 5 is where the heading opening tag is. Okay, so maybe it is the same. Anyway, so there's 5 items, and here's an example. This is the actual definition, in an abstract sense of that. There are a couple other things can happen, as we mentioned during class, when you're doing this opening and closing and nesting validation. One of them is if the stack's not empty when you get to the end of the document, that means that there's an unclosed tag at end. And so you build up a smaller list that's got 3 elements. One other thing that can happen is while you're processing, you could bump into a closing tag, but the stack was empty, even as you're processing the document. And that's an orphan closing tag and described like so. Okay. What else did I want to say there? Oh, yes, good. So now the basic XML tag stack where you have to implement push, pop, peek, and get count, those are pretty straightforward and trivial. As I mentioned, you can take a look at the guidebook for an example, and that's just fine. But for the validation, that's non-trivial. And in fact, one of your biggest problems when you go to validate is, how do I get this tag and that tag and this tag and that tag and so forth? And one possibility is you can do searches for angle bracket. You string that index of. This can be done and has been done successfully in the past, but it is a painful process, I would say, to say the least, okay? Particularly because these tags can have attributes inside of them. And it's attribute 1 equal this. They can be on different lines, even attribute 2 equal that, and so forth. So it can be really tricky to have code a tag that starts on one line, ends on another line, and still pick them all up and not miss anything. So, but this is a tailor-made problem for regular expressions. So I have an example for you that you can download from the web page for the class right above the assignment itself, called Regular Expressions Example. And just to give you a sense of what this does, here's an XML file that's got a prologue statement. By the way, that's one you can ignore, but a bunch of tags as well. And then I'll run this program just so you can see what the output is. The program runs a loop, and it literally goes and gets out each tag. Okay, gets that tag and tells you not only what the tag name is, but then also prints out the location where it's at. And gets catalog, and notice it's located at 11, and CD. Notice that it does get the entire CD tag, even though it happens to cross lines. So it gets the whole tag for you, and then notes what line it's on, or linear index it's on, not the line number. The position inside the string, I should say. Anyway, but it gets all the open tags and the close tags. And I don't think yes, I even has, so open and close tags. It doesn't tell you what's what, but with a little bit of Java code, you could tell that, oh, hey, the second character of this one is a slash, so this must be a close tag. One other thing I should mention, it does get the self-closing tags. Notice that they've got the slash just before the angle bracket at the end. They're called self-closing tags. Those you can ignore for the nesting validation process because they both open and close in one tag. They can't be wrong. Well, okay, so this has got a loop that does this, and it's not very many lines of code. And my recommendation is that this code right here form the basis, let's say the core starting point of your validate method. A couple things to say there. First of all, your validate method receives an XML string already loaded up. That's why I didn't really describe this as part of your core for the validate method, because this reading of the file will be done by the calling routine, the grade script. You're going to get something that's closer to the contents of the file. Okay. But then the way regular expressions work, and I'm not going to give a detailed description of it, but they're like a wildcard search on steroids. And so here is our search pattern. They call it a pattern. And let me try to break this down. It says, I'm looking for an angle bracket, open angle bracket. And then basically anything that is a hat character here is not an angle bracket, okay? And the brackets mean kind of basically anything that matches this little sub pattern. And the plus means many of them until you bump into a closing angle bracket. So let me break that down one more time. I'm looking for an angle bracket and then anything that's not an angle bracket until you get to an angle bracket. Okay. And so it'll basically look for a match to this pattern. But that's just a description of what I'm looking for. It doesn't say what to look at. It doesn't just naturally know which variable to look at. So what you do is you take that pattern and you match it against some text you want to search through. Once I have that, that doesn't do all the work. All the work happens inside of a loop. Okay, and M is my matcher. And by calling m.find, I go find the next match. And it will start off at the beginning of the string and keep going all the way to the end of, in this case, the XML. Each time it makes a match, like for example, up here, when it matched the prologue, it'll stop and m.group will be the matched text. So what I have highlighted down here, the prologue statement, I think it's called prologue statement, anyway, is the m.group there. Okay. And then m.start, okay, each time is the location where the match occurred. So here it matched up at index 1. Anyway, this program continues, then it keeps looping as long as another match is found in the file. And of course, it's just searching for tag. It's going to find a bunch of them, right? The loop happens many times. Okay, so next time through the loop, it'll go off and do a find. It'll find the next match. And in this case, then it's catalog. Catalog is m.group there. Okay, so m.group is always the matched text. And then, of course, as I mentioned before, m.start is wherever that text starts matching. And this just keeps looping it for all of them. Eventually, when it gets to the end of the document, there are no more tags, and m.find will return false. That's what breaks us out of the loop. A couple of little tidbits to point out there. What were they? I'm trying to think right now. First of all, right, the first thing I should point out is that it automatically ignores the data text, okay? We're just trying to match up the tags, not the data inside the tags. And so we don't want those printed out. And you'll notice from this little output here, if you go run this program, and I highly recommend you do download it and run it, that the interior text is not printed out. Okay, because you want to ignore that anyway. That's the first thing to say. And there was something else, and now I can't quite remember there. Okay, right. Notice that the m.start is the linear index, the position within the string, not the line number, because catalog, for example, if I look at the file, catalog happens on line 2, but it's at position 11. My recommendation is that for your XML tag, when you go to push this thing, I would push the word catalog. I'd strip off uh, the leading angle bracket and anything after the tag name. And I would also push in the tag index as 11 there. Don't worry about changing that to a line number because in general, for one thing, this file could be very large with many, many, many tags. If there are no problems, you never need a line number. Okay, so why go to the work? Even when is a problem, though, it's still not worth it because in general, if there are many, many tags, we're only going to report the very first error that occurs. Okay, so that's something else to know. When a problem occurs, a tag mismatch or an empty tag or something like that, you should stop right there and build your results array and then just return it, or results list and return it. Don't continue on because all the other errors would just be, they would be cascading errors anyway.